Hello class, welcome back to another Chem 21 organic chemistry lecture. And for today we will be talking about triglycerides or triacylglycerols. By triacylglycerols and triacylglycerides, you may see here that we will be talking about three something or triglycerides or triacyl with glycerol. So, ano ba 'to? So, by triacylglycerol and triacylglycerols or simply fats and or oil are naturally occurring mixtures of triesters formed between glycerol and long chain fatty acids. So basically, you will be this is just a continuation of our discussion regarding carboxylic acids, wherein for today we'll be looking into those long chain fatty acids in combination with glycerol. As you may see here, glycerol is just an organic compound having three hydroxyl groups. So wherein these three hydroxyl groups are actually attached to adjacent carbon compounds or straight chain carbon compounds. And we will be attaching those uh, glycerols to long chain fatty acids. By long chain fatty acids, this long chain fatty acids actually has at least 12 to 26 carbon atoms. So, yun yung titingnan natin dyan. When we say long chain fatty acids, ito yung mga carboxylic acids that have that has 12 carbon, at least 12 carbon to 26 carbon atoms. So these compounds were first isolated using galing sila sa mga naturally occurring fats. So that's why we say that fats and oils are naturally occurring mixtures of triester formed between glycerol and long chain fatty acids. So this will be our glycerol here. And as you may see here, we have here one, two, three fatty acids. And the combination or the mixture of those or the bonding of those, magkakaroon tayo ng triester. As you may see here, we have here tatlong ester. And that triester is actually what we call triacylglycerols or pwede natin siyang tawagin na TAG or tag. So those tag ay simply mixtures lang ng mga pinag-usapan natin last time. And by pinag-usapan natin last time, we will be looking into the structures of tag. So triacylglycerols can actually occur in different forms or different structures. So, pwede itong maging simple or pwedeng mixed depende rin sa fatty acid residues na present dun sa ating triacylglycerol. So, as you may notice here in the first example, pare-parehas yung mga acyl natin na nakakabit dun sa ating glycerol. As you may notice here, all of our acyl have, for this one, we have 14 plus 1, 15, 7 plus 1. So we have 16 carbon atoms in this acyl. We also have 16 carbons for this acyl and also 16 din sa parting ito. And in that, this is what we call the simple triacylglycerol or simple TAG. Okay? And in some scenarios, magkakaroon tayo ng TAG or triacylglycerol na merong halo-halong residues or by the residues yung ating mga acyl compounds dito. So as you may see here, we have here this 16, we have here this 18, and we have here the 16. So this is yung tinatawag nating mixed TAG. Bakit siya mix? Simply kasi magkakaibang acyl residues yung connect dito. Kasi magkakaiba yung fatty acids na nakakonect dyan sa mga yan. So, by fatty acids, as you may have remembered last meeting, we actually discussed some long chain carboxylic fatty acids. we categorize them into saturated fatty acids and unsaturated fatty acids. So as you may see here, the smallest fatty acid may dahil ito ay hindi siya 12, pwede natin siyang i-disregard. But the simplest form na pwede natin or yung pinakalaging present ng mga types or yung pinaka-common ng mga fatty acids actually ay itong apat na ito. We have the lauric acid, the muriatic acid, palmitic acid, and stearic acid. Ito yung pinaka-common na mga saturated fatty acids. And as for the unsaturated fatty acids, we actually have three common unsaturated fatty acids. Andyan yung ating oleic, linoleic, or linoleic, and linolenic acid. So, yan yung tatlong yan. Okay? So, those are some of our long-chain fatty acids na common. Pero last meeting, I actually presented different types of this saturated fatty acids wherein meron nga tayong 6 at 5 uh, limang examples. So, 6 na examples para dun sa ating saturated fatty acids and 5 example para dun sa unsaturated. So, bakit ko pinili lang or bakit ko binilugan lang yung mga ano natin, yung mga common na yan. So, let's, because we will be looking to the structures of the common fatty acids. So, by structures of common fatty acids, tingnan na natin yung sinabi ko last time regarding dun sa saturation or yung tinatawag nating saturated fatty acids. So, by saturated fatty acids, ipakita ko lang muna yung form. So, by lauric acid, as you may see here, we actually have 12 carbon atoms here. One from the acyl, we have 10 dun sa chain, tapos meron tayong terminal na isa. So, we have 1 plus 10 plus 1, that is 12. So, ano ba yung itsura niyang ng saturated fatty acid niyan sa way kung paano natin siya isinusulat natin. So there are actually several notations that we can use for this for structures of fatty acid. So pwede tayong gumamit ng fish curve, pwede tayong gumamit no yung compressed na form, pwede rin tayong gumamit nung ginagamit natin na usually yung sticks na. So pakita natin yung tatlo. So these are the common alternative notations for lauric acid. Kasi as you may notice here, medyo hindi natin makita mismo yung structure ng lauric acid kapag ganyan yung itsura niya. Pag molecular formula yung binibigay sa atin. So ipakita natin yung mga notations. So ilan dun sa mga notations na yan, itong isang ito, since we have their 12 carbon atoms, we can just simply write 12 carbon atoms here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, ito yung pinaka-tedious na notation na ginagamit dito. So, ang gagawin nyo lang, locate nyo lang kung nasaan yung acyl nyo. So, yun ay nasa dulo. So, sulat lang natin siya as acyl. Then, we just need to bond all of those carbon atoms to each other. Mas okay sana kung pantay-pantay yung spacing nila. Then, we just need to write all of their hydrogens. Tatlo para dyan, dalawa para dito, and dalawa para dito. Then, ganun lang ulit. Shortcut ko na yung pagsusulat. Again, mas okay kung pantay-pantay yung pagkakasulat ng mga hydrogens natin to para maging uniform yung mga bond lengths natin. Basically, that is one of the notation of our lauric acid. So, pwede nyo siyang isulat lang as straight chain. As you may notice, saturated fatty acid ang ating lauric acid. So, ano ba yung sinasabi nating saturation? By saturation, it is actually due to the presence of our hydrogen atoms. As you may see here, we actually have a lot of 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 hydrogen atoms here in lauric acid. So, kung titingnan nyo actually, meron dyan tayong 20 dito sa loob na to, dito sa mga yan. Then, we have another 3 here. So, that's 23 plus 1. So, that is actually a total of 24 carbon atoms. 24 hydrogen atoms pala. So, as you may see here, yun yung tinatawag na nating saturated fatty acid. Kasi in comparison with unsaturated fatty acids, mas maraming hydrogen ang ating mga saturated fatty acids in comparison with our unsaturated fatty acids, which we will be seeing later. So, na pwede natin gamitin when we are writing our dodecanoic acid or yung tinatawag nga natin for this part ay yung ating lauric acid is we can simply write it this way. So, kunin mo yung nakahiwalay na terminal carbon. So, you just write CH3 there. Then, you just write a bond here. Then, you just rewrite this one. So, you will have here CH2. Then, you just write 10 under there. Then, you just need to draw your acyl or your carbonyl group. So, ganyan yung magiging structure niya. So, bali, nire-write lang natin yung ating formula in a way na mas makikita natin kung paano siya structure. So, ganun din yan para dun sa myristic acid. So, pwede nyo rin gawin na isulat nyo lang din yung CH3, itong part na ito. Then, you just need to write the bond. Then, you need to write CH2. Then, kopyahin nyo lang yung nasa baba. Then, we have here our COOH. So, that is your myristic acid. And also, pwede rin yung palmitic acid. Ganun din lang din gagawin niya in steric acid. And knowing na saturated fatty acid sila, pare-parehas na magiging ganito yung itsura nila, yung nasa pinakataas, mas mahaba nga lang yung myristic acid natin, palmitic acid, and steric acid kesa dun sa lauric acid. And also, another notation na pwede natin gamitin ay yung usual na natin ginagamit. Ito kasi, itong usual na ginagamit natin ito, pinapakita kasi nito yung yung structure mismo or kung paano nakabend or paano spaced yung ating mga carbon atoms sa isa't isa. So as you may see here, yung ano ba yung ginagamit natin dati? Yung puro sticks lang actually. So, kung maaalala niyo yung sinasabi kong puro sticks, so pwede kang mag-start dun sa iyong carbonyl carbon. So, isulat mo muna yung andito yung OH mo, andito yung double bond. So, itong segment na ito, itong endpoint na yan, yan yung una mong carbon atom. So, ibig sabihin, yan yung magsisignify dun sa carbon ng ating COH. Then, you just need to draw ng 10 pa ulit at isa pa para makumpleto mo yung iyong lauric acid. So, pwede kang mag-count. Simula ka rito ng 1. This is your 1. Then sa portion na yan. Then, 1, 2, 3, 4, 5. Ulit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, mas madali itong isulat kaysa dito sa isang to. Kasi hindi mo na kailangan isulat yung mga hydrogens mo. It just signifies na for each of the corner here, meron kang hydrogen at saka carbon atom. So, bilangin lang ulit natin yan. So, check lang natin kung 12 carbon ba yan kasi ang lauric acid ay 12 carbon fatty acid. So, check lang natin. So, this will go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, sakto siyang 12. Ganun natin siya pwedeng isulat. Pwede nyo rin namang isulat na COOH lang yung nasa dulo, nasa sa inyo naman yan. Pero, same concept para dun sa myristic acid. Pwede nyo rin namang baliktad rin yung structure niya na nasa kaliwa yung carbonyl para hindi papuntang kaliwa yung pagsusulat niyo. So, halimbawa, yung sa myristic acid, kung gusto natin siyang isulat, gusto natin siyang i-drawing yung structure niya. So, pwede nating simulan dito sa dulo. So, andito yung iyong double bond, andito yung iyong OH. So, start ka rito. Since bilangin mo na lang muna yung carbon ng iyong myristic acid. So, you have 1 here. Then you have 12. So, that's 13 plus 1. That's 14. So, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, pwede mong i-check yan ulit. So, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 11, 12, 13, 14. So, bawat end ng segment mo or ng line mo ay may isang carbon. So, that is your myristic acid. So, yung gano'n natin i-drawing yung ating mga fatty acids. So actually, it also mimics kung ano yung itsura niya talaga sa nature. So dahil ang carbon ay may apat na valence electron sa paligid niya. So ang tendency niya actually, ang tendency ng spacing natin ay magkakaroon kasi tayo ng tetrahedron. So yung tetrahedron na yan, itong isang bend na to, yun actually yung nire-represent ng pagliko or yung angle ng bawat bond natin dito. Kaya natin siya isinusulat na ganyan. Okay? So that is how we are structuring our fatty acids or how we are noting our fatty acids. So ang suggestion ko, ang test na gamitin nyo sa pagsusulat ng ating fatty acids ay itong last. So yan yung pinaka okay gamitin in writing your fatty acid. So though ang pinakamadaling isulat ay itong isang to. Ang problema kasi sa isang to, pwede siyang magpakita rin kasi ng structure ng iba pang fatty acids na saturated na ganyan din yung itsura. So kung hindi ka careful, maaring magkamali ka sa sa paggamit nito. Okay? So, let's move into the next structures of common fatty acids. Kasi ito, ang structure na to ay itsura ng ating mga saturated fatty acids. So, how about our unsaturated fatty acids? So, last time, pinakita ko tong ganitong itsura ng ating mga fatty acids. So, we have here three common fatty acids. Kung mapapansin nyo, actually, pare-pareha sila ng number ng carbon yan. Lahat sila ay may 18 carbon atoms. Ang pinagkaiba-iba lang ng oleic acid, ng linoleic acid, at saka ng ating linolenic acid, actually, ay yung dami ng kanilang double bond. As you may notice, for oleic acid, we actually have one double bond na nandyan. And we have two double bond for our linoleic. And for our linolenic, we actually have three double bonds. So, yung mga equal na yan, yung mga mukhang equal na yan, actually ay mga double bonds. So, paano natin siya isusulat dun sa structure na pinakita natin kanina? So, unahin natin yung leic acid. As you may notice here, for oleic acid, kung andito yung count natin ng 1, since ang pagka-count na or pagbibilang natin ng straight chain ay nag-start tayo lagi dun sa ating functional group. And ang functional group natin dito yung ating carboxyl group, yung ating COOH. As you may notice here, if you count kung ikailan yung carbon na nagkaroon ng double bond, ay bibilangin mo siya, you have here 1 plus 7, that is 8. This is 9 carbon. So, ibig sabihin, yung double bond natin ay nasa 9, 10. So, paano natin siya isusulat dun sa form na ginagawa natin kanina? You can actually write that dun sa ikalawang form na ginagamit natin this way. So, pwedeng sulat mo muna yung iyong COOH. So, you have here your COOH. Then you just need to write here CH2. Ilan yung CH2 na yan? Susulat mo lang ulit yan, 7. Then you have here your CH, which is double bonded to another CH. Then, meron kang single bond ulit. Tapos, meron kang CH2. Yan ay 7 times na nag-4 yan. Then, you have here your CH3. So, basically, ganyan din yung magiging itsura ng ating ng structure ng oleic acid natin. So basically, what will happen here is you will have this structure wherein kung andito yung iyong COOH or yung ating carboxyl group, then you just need to count up to 8. Tapos yung 9, doon ko magkakaroon ng double bond. So, makita lang natin na. So, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9. Then magkakaroon ka ng double bond dun sa 9. Then 10 ito. 11, 12, 13, 14, 15, 16, 17, at hindi siya nagkasya. Ulitin lang natin. So, dito ko simulan sa kabila. So, we have here our COOH. Okay? So, that is 1, 3, 4, 5, 6, 7, 8, 9. Double bond about dun sa 9. 10, 11, 12, 13, 14, 15, 16, 17, 18. So, yan yung magiging itsura ng ating oleic acid. And as you may see here, class, pwede na natin actually makuha dito yung kanyang systematic name. By systematic name, papakita lang dito kung ano ba yung pangalan mismo niya using our IUPAC system. So, ganun lang ulit, ganun pa rin yung magiging system natin. Magsisimula ka rin sa functional group. Kunin mo lang yung longest chain. So, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Ibig sabihin, kung meron kang 18 carbon, anong ibig sabihin nun? Meron ka na ngayong octa uh, deca. Octa-deca, kasi 18, 8 plus deca, which is 10, kaya siya naging 18. So, dahil ito ay COH, ibig sabihin, papalitan natin yung E ng oic. So, magiging pangalan nito ay octa-decenoic. Bakit decenoic? Bakit, sir, hindi deca? Kasi meron tayong double bond. So, basically, this will be our cis 9 octa decenoic acid. Sir, ano yung cis9 na yan? Ang ibig lang sabihin natin dyan, class, nire-represent lang natin yung double bond natin na nasa 9 kasi yun yung lower na number, hindi yung 10. Bakit siya cis? Kung papansinin nyo, class, parehas ng side nag-open up papunta ron sa carbon bond natin, yung ating bond. At kung papansinin nyo rin kung nasan yung kanyang hydrogen, kung idadagdag natin yung hydrogen dyan, yung hydrogen natin dyan ay parehas sila ng side. And pag parehas ang side, alam natin, tinatawag natin yung cis. Kaya ito ay cis9 octadecenoic acid. So, drawing ko na lang din yung linoleic acid. By linoleic acid, as you may see here naman, ganun lang ulit, count mo lang ulit. Start ka ron sa iyong COOH, kung ilan yung carbon bago mag-double bond. So, this is 1 plus 7, that's 8. So, ibig sabihin, 9 ulit ito. 9, 10, 11, tapos may double bond ka ulit dun sa 12, 13. So, wala na ulit double bond. So, ang mga notable na number dito ay dapat may double bond tayo sa 12 at may double bond tayo sa 9. So, ibig sabihin, halos parehas lang din yun dun sa ating octadecenoic acid. Madadagdagan lang tayo ng double bond about dun sa ating carbon 12. So, ganun lang ulit. You just need to write your OH here, then your oxygen here, double bond oxygen. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. Double bond. Okay? 10, 11, 12. Double bond ulit. 13, 14, 15, 16, 17, 18. So this is our linoleic acid. And as you may see here, we have here dalawang double bond sa 9 at sa 12 na carbon atoms. So gusto nyo check, pwede nyo bilangin. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So, 18 ulit siya. Ibig sabihin, octadecane ulit siya. Meron nga lang tayong dalawang bond or dalawang double bond. Ibig sabihin, ito ay magiging diene. And by diene, since ito ay may OH, papalitan lang natin yung E ng diene ng oic acid. So, this will be, para dun sa naming, so this will be 9,12 octa de kasi octa de kasi yung ating decane which is 10 as octa which is 8. Uh, then meron tayo syempre dienoic. So octadeca dienoic acid. Okay? So yan naman yung sa ating linoleic acid. So that is 12 9, 12 octa decadienoic acid. So, in here, kung mapapansin nyo, cis-cis ulit yan. So, pwede nyo isulat yan as cis-cis. Lagyan nyo lang ng pares na ganyan. You're just saying na dun sa dalawang double bond, parehas na cis conformation yung nangyayari. So, ano ba mangyayari kapag hindi cis-cis yung conformation? Liliko yung bond nyo. Liliko yung inyong long chain ng inyong fatty acid. So, imbis na ganyan yung itsura, magiging siya, pataas, pa ganyan. Then, ganyan na yung magiging itsura niya. Hindi na siya magiging straight chain dito. Okay? So, kailangan cis-cis siya. Okay? So, pakita na rin lang natin yung sa linolenic acid. So, ganun lang ulit yan. Papansin nyo, we have here 1C plus 7, 8, 9. So, this is 9, 10, 11, 12. So, 12 ulit. Saka 9 ulit. 13, 14. So, meron tayo dito 15. So, wala na tayong double bond. So, again, we have double bonds starting at carbon 9, carbon 12, and carbon 15. So, i-drawing ulit natin yan. Ganun lang ulit yung system. Sulat mo lang ulit yung iyong OOH. And ito yung C mo. That's your first C. Dito sa, na yan, sa bandayan. So, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you have here your double bond. 10, 11, 12. This is 13. So, partner ko. 13, 14, then 15, 16, 17, 18. So, this is your linolenic acid. So, as you may see here, since ito ay 9, 12, 15, you just need to rewrite it that way at imbes na di, magiging tri lang ito kasi tatlo yung double bond natin. So this will be 9, 12, 15, octa, deca, traye. Bakit tri? Kasi tatlo. N, bakit may N? Kasi meron tayong in dito, alkene, tatlong alkene. Tapos oic, kasi meron tayong carbonyl, tapos acid. So, pwede nyo rin niyang isulat as cis, cis, cis. Kasi tatlong cis configuration ulit yung meron tayo. So, those are the structures of our common fatty acids. So, we have here the cis-9 octadecanoic acid. We have the 9,12 octadecadenoic acid, which is cis. And we have here the 9,12,15 octadecatrienoic acid, which is cis. So, kung ako sa inyo, may memorize ko na lang yung mga common name nila. Kasi mas mahirap pangalanan sila using the systematic. But in any case, since na ano na rin naman natin, napakita na lang din natin yung kanilang structures and common fatty acids, ipakita na lang din natin yung kanilang notable properties ng mga fatty acids. So, by notable properties of fatty acids, isa sa mga lagi nating nakikita or na-encounter pag pinag-uusapan natin ng fatty acids, syempre ay yung mga mantika at saka yung mga taba. So, by mantika, taba, fats, and oils. So, those fat and yung melting point na sinasabi natin, yung pagkatunaw, usually doon nakikita natin yung mga oils natin, sila ay nagsisolidify. So, yung solidification actually na yun, at saka yung pagkatunaw niya, actually ay related sa melting points na nakadepende rin sa ating mga hydrocarbon chains or dun sa length ng hydrocarbon chains natin and sa degree ng unsaturation. So kapag unsaturated, ano ba yung effect ng unsaturated na fatty acids at ano yung effect ng long chain ng hydrocarbon ng ating mga hydrocarbons. So for dun sa mga saturated natin, kung mapapansin nyo, ito ay actually arranged ng pahaba. So lauric acid has 12 carbon atoms. Myristic acid has 14 carbon atoms and 0 double bonds. Palmitic acid actually have 16 carbon atoms and stearic acids have 18 carbon atoms. And syempre lahat sila ay walang degree ng unsaturation kasi lahat sila ay walang double bond. So sinasabi lang natin na kapag ng isang fatty acid ay may degree ng unsaturation kapag meron tayong double bond. Pag wala tayong double bond, wala tayong degree ng unsaturation. So as you may see here, kapag mas pahaba yung ating fatty acid, pataas din ng pataas yung kanyang melting point. And as you may notice naman, kapag tumataas yung degree ng unsaturation, pababa naman ang kanilang melting points. As you may see here, since tatlo yung ano natin, yung double bond natin sa linolenic acid, mas mababa ng sobra yung kanyang melting point kesa ron sa isa lamang yung degree ng unsaturation. So, anong ibig sabihin nito? So, kapag pahaba yung length ng hydrocarbon chain, anong ibig sabihin nito? Pataas yung ating melting points. Bakit hindi boiling point yung ginamit natin dito? Kasi mas napapansin natin yung melting points ng ating mga fats and oils. And also, kapag padami ng padami, yung degree or pataas ng pataas yung degree ng unsaturation, ano nangyayari? Pababa naman yung ating melting point. So, yan yung nangyayari sa ating sa ilang mga properties ng ating fatty acids. Depende kung ano yung kung anong haba ng hydrocarbon chain niya at saka nung ating degree of unsaturation. So, ano bang relevance nito dun sa nangyayari usually sa buhay natin? So, kung ano ang nangyayari sa buhay natin, kasi class, wala naman tayong fats and oils na purong saturated at unsaturated lamang ang kanilang mga fatty acids. So, ideally, here are some of the fatty acids composition of some selected fats and oils. So, dinivide ko yan into two. As you may see here, we have fats and oils. Then, we have here percent composition ng mga yun. So, dito sa side ng kaliwa, yung ating mga saturated fatty acids at yung mga unsaturated fatty acids naman dun sa kanan. So, as you may see here, kapag titingnan natin yung ating mga fats, which are usually derived from animals, so, ang lard usually galing yan sa taba ng hayop. Human fat, syempre sa tao. Okay? So, animal pa rin. Then, we have beef tallow, yung taba ng baka. As you may see here, in comparison with some oils, mas mataas usually yung concentration ng mga saturated fatty acids natin kesa ron sa mga nasa oils natin sa baba. As you may see here, yung ating beef tallow ay meron siyang 5% na myristic acid, meron siyang 28% na palmitic, at 23% na stearic. And that alone ay nasa 51 plus 56% na. So we have here 56% of beef tallow is actually saturated fat, and only 43% is unsaturated fat. So in that, as you may see there, mas mataas yung percent compositions ng mga fatty acid natin in comparison the uh, with the oils. Kung papansinin nyo, yung corn oil, olive oil, and peanut oil, almost laging less than 20% lamang ng kanyang percent composition yung saturated. So, ano ba ang nagiging basis or ano yung kabuluhan nito? So, pag nakakita kayo ng oil, na usually ay mas mabilis mag-solidify kaysa ron sa sa mga usual na oil mo. Isa lang ibig sabihin yan. There is a higher degree of saturation. Mas maraming saturated fat yung ating oil na yon kaysa sa unsaturated. So, ano ba ang kabuluhan nun sa buhay natin? So, ideally, sinasabi nila, though hindi ako mag-go into deeper dito kung bakit ganun yung sinasabi nila. Mas healthy kasi para sa atin ang unsaturated oil kaysa sa saturated oil. Ibig sabihin, ito yung part na check at ito yung part na X. So, in that, mas mapipili natin kung ano yung mga oils at fats na i-consume natin in comparison kung ano yung usual na natin alam. But basically, yung idea na yun, actually, merong kaunting background or kaunting pwede nating sabihin na pwede nating lagyan ng kabuluhan in some sense. So, yun ay i-discuss natin next time kapag pinag-usapan na natin yung reactions ng fats and oils. Pero i-exclude ko yung ilang reactions na or yung mga pathways or yung mga enzymatic degradation and kung ano-ano pa na related sa mga i-discuss nyo sa inyong biochemistry. But in that, that will be all for this video. Thank you and have a great day. Bye.